Grade 12, this is Mechanical Analytical 3, and there are 5 views and a detailed enlargement of a shifting spanner assembly, a part list, a title block, and a table of questions given to you. The drawing have not been prepared to the indicated scale. So you need to complete the table below by neatly answering all the questions which refer to the accompanying drawings on your left. So we are going to look at all these views that we have there of a shifting spanner. Right, let's start immediately with the first question, and question number 1 is going to be what is the title of the drawing, and we're going to scroll down to that title and write it in. Here we see the shifting spanner title, so we're going to write that into our answer block. Question number 2, what scale is indicated on the drawing? That scale of 1:1, which we are going to have in our answer block. Question 3, what drawing program was used? And that's going to be AutoCAD 2017. Question 4, on what date was the drawing drawn? It was drawn by Werner, and it was on the 8th of the 1st, 2017. Let's write that in. Number 5, who approved the drawing? Here you will find that the drawing was approved by a person by the name of Stein. Question number 6, what is the radius of the unspecified curves? We're going to find that in our title block. All unspecified radii are radius 2. Question number 7, what material is used to manufacture the adjustable jaw? Let's go see. And the material used to manufacture that would be tool steel. Let's write tool steel in our answer block. Number 8, what type of heat treatment is required for the jaws? The heat treatment for all jaws would be hardening. Let's write that in. Question number 9, what projection system has been used for the drawing? And that is going to be, without a doubt, third orthographic projection, because of the fact that this mechanical drawings are all in third orthographic projection. Number 10, determine the dimension at A. Let's go find A. A refers to the length from top to bottom. We are going to have 40 here from there to there, and we're going to have 80 from there to there, which is going to be 120. All we need is this little part over here, and if you scroll over, you're going to find that from that center point to the most outside semicircle is going to be 8 millimeters, radius 8 millimeters, and we're going to add that to our 120, which is going to give us 128, which we are going to write in our answer block. Number 11, measure the angle at B. So we're going to go and see where B is and measure the angle. Now for you to be able to measure B, you will have to look at this specific angle here, that being a nice and straight line, and you are going to have to extend that angle a little bit longer, and then you are going to apply your protractor on here by putting your protractor center point in that corner, lining up this line with your bottom line, and then finding that angle right here where it strikes on 90, where it strikes on 78 or 79, both that would suffice. 78, 79. Number 12, what is the purpose of the measurements on the fixed jaw and the handle at C? Let's go have a look. So these are the values on here, to be able to open this mouthpiece here to a specific size. That would be the jaw opening size. Alternatively, it could be the specific size to be set, or it could be the verification or determining of a specific size which you would like this jaw to open. So any one of those you can write down as your answer. So as I've mentioned, it's either to set to a specific size, and that is your purpose, or that would be the jaw opening size. Number 13, name the type of sectioning at D, as well as number 14, name the type of sectioning at E. Let's go look at both. You are going to find that D refers to a specific detail, and that's why we have the wavy line there. So that's going to serve as part section. And if you look at E here, E is drawn inside the component and shows what the shape of the component looks like, and that will serve as a revolve section. Let's go write in those answers. Question number 15. What is the purpose of the grooves at F? So the grooves here at F will assist you to have a better grip when turning, and it makes turning easier. Let's write in that answer. Number 16. If view 2 is the front view, what would view 4 be called? So if we analyze the view, if that is your front view, that's going to be your left view. This is going to be your right view, which is view 3. You're going to have your top view here above the front view. Then this will be your rear view, or the view on the other side, which is your back view as well. Number 17. What is the purpose of the enlarged detail view? And it's exactly self-explanatory. The detail view shows detail. Number 18. What type of section resulted from the cutting plane SS? If you look at the cutting plane here, SS, it really takes the shape of the shifting spanner, the way it tilts. So that aligns according to the shape of the component, which brings us to the answer of an aligned section. We look at number 19. With reference to the tolerance, determine the minimum dimension at G. So here we have G, and you're going to find that there is a 4 millimeter dimension there, and you have a plus 0,15 and a minus 0,25. The minimum would refer to the minus 0,25, so 4 minus 0,25 is going to give you an answer of 3,75. So question number 20, how many surfaces of the fixed jaw and handle must be machined? So we are going to look at these machining symbols that we see here, and I'm going to highlight them. It's going to be 1 there, which refers to that surface, 2 there, that refers to that surface on the slant here. Then that's going to be 3, which is that slanted one. That's going to be 4, that slanted one there. But this one, boys and girls, refers to 3 surfaces. And I want to take you to the side here. If you look at this here, it's referring to that side there, the side on the other side of that, which is identical, and the middle one. Those are the 3 that need machining. So it's going to be 1, 2, 3, and if you add 1, 2, 3, 4, because that represents this over here, which is going to be 7. So your answer is going to be 7 in your answer block. Then question number 21, what direction of lay must be applied to the machining surface? So The direction of lay, the information is going to be found in your mechanical notes. And if you look at the symbol right here at the bottom, which is that symbol there, you're going to find that that upside down T refers to the direction of lay, which is something like that. And that symbol is going to be perpendicular. So this line is perpendicular to that line. Hence, the answer would be perpendicular is the direction of lay. And question number 22, which is the final question, in the space below, in this answer block here, draw in freehand the conventional representation of a bearing on a section of a shaft. So you've got to draw the shaft first. So basically what we're going to do, we're going to draw the shaft first. And remember, the shaft continues. That's why we are going to have S brakes here. So there's your S brake. You're going to have another S brake on this side. And there we have the S brake, meaning it continues. And then, of course, we are going to put the bearing right here in the center. So half of the bearing is going to come out on top, and half of the bearing is going to come out at the bottom. And all we do is we need to cross that to be able to show that that is a bearing. Just don't forget to add the center line right in the middle here, which is also going to be half a mark. So that, learners, concludes this particular analytical 3. I hope you've gathered enough information to take you into the next one.